So I'm going to show how to solve the OpenAI Gem's cart pole problem. Just for fun, we're going to solve this using reinforcement learning and a neural network. So first I'm going to just create a file called cart pole, and then create a class called learner. And I'm just going to set things up here so that it runs when we run this file. Just going to make a method here called run. Okay, so in the run method, we want to loop through the number of attempts for this cart pole. So the number of attempts is going to be, and we'll just call it tries. So we can pass that in. And we'll let it try 2,000 times. Now, in the constructor, we want to create our environment. Say, I'm going to use cart pole v1. Okay, now here, basically going to reset the environment and get a state object. There we go. So this state object is going to have 4 data points in it. Data points are going to look like the following: position, velocity, pole angle, and the pole velocity at the tip. Okay, now what we're going to do is just keep track of the number of steps that that this game is making. This is sort of like frames. And we're going to render the environment so that we can see what's going on. Now, we need to take some kind of action. So we need to step this environment, which would be like this. And we can give it 0 or 1 for the action. So basically, 0 is move left and 1 is move right. So we can test that, I guess. And just say always step 0. And let me see if I can just run it and see what it does. Yeah, so 0 always moves left. Let's just tell it to always step right. There we go. So basically the idea is to figure out whether or not we should be passing in a 0 or a 1. And we want to create an algorithm that learns how to keep the pole upright using these data points that we have. Okay, so we basically have to figure out whether or not we should pass in 0 or 1. How do we do this? Well, the step function returns a observation. Actually, we can just command click into here, figure out what it returns. So it returns an observation, the reward, whether or not the cart has fallen over, which is the done variable, and then some info. We don't need all of it. So we're going to just go like this. Use the info. And the reward is always, it's always a 1. So don't actually need it. So observation is the new state after we've taken our action. So basically we have the current state. We take a step in one direction or the other, and then we have the new state. And then we know whether or not the cart has fallen over, and I believe it's 15 degrees says that the cart has fallen over. Okay, so we want to create the ability to remember all the steps that we took and the state that it was in, as well as the state that happened after we took that step. So we're going to create memory. And for this, we can just use deck. Collections, say it's allowed to keep 100,000. Yeah, 100,000. Okay, great. I'm just going to put the stuff in the memory. We want to remember current state, the observation, and then whether or not it was done. That's it. So we're going to remember every one of these steps that it takes up to the maximum size of the memory. Now, what are we doing here? We're using a reinforcement learning technique that's called Q-learning. So what we want to do is we want to build up a list of actions that we took with a state and then observed outputs that happened. This is going to build a data set that we can train a neural network on, but it's going to build it on its own. We don't have an existing data set. It's going to build this data set as we go. Okay, so we're going to need a neural network to train. So let's create that. And I'm going to use TensorFlow for this. We're going to use the sequential model. And then fully connected layers. Use just 24 nodes, ReLU activation function, input dimensions. This would be 4 because we have 4 data points here. We can actually get that from the environment. So okay. Now we want another fully connected layer. So the ReLU activation function is probably good enough. And then we want an output layer. With 2 nodes for the output because neural network is going to predict 0 or 1. So we're going to train these middle layers and it's going to predict 0 or 1. And then we'll just say self.model.compile loss. Going to be mean squared error. Optimizer is going to be the atom optimizer because that's just a good one. We want optimizers v2. Learning rate is going to be 0.01, which is kind of a standard. And then the decay is going to be 0.01. Great. I mean, these are some just easy parameters for this network. It's a very simple, straightforward network. Nothing really special here. But in order to put things into the network, we need them to be in sort of a rows and columns shape. So we're going to use NumPy to reshape the state. Because this is going to give us something that's just got 4 values. So it's like a list with 4 values. This is going to give us something that is a list of lists, sort of. It's going to be a matrix, but with only 1 row in it. And then we want to do the same thing for observation here. I'm going to save it to the memory. That's great. Now, I'm just going to say that the new state is equal to the observation that came out of the step function. Okay, but where do we want to get the action that goes into the step function? We want to do this. We want to say action, and then let's create a function, get action. We'll pass in the current state. Okay, so what we can do is we can literally just use our network to predict the action that we should take and return that. So predict state. What this is going to give us is a prediction for the 0 and for the 1. So we want to figure out, is it 0 or is it 1 that we want to return? So the output is going to look something like, it's going to be a list with a number, a value, sort of like this, in each position. And the larger value number, so in this case, the number that's in position 0 is our better prediction. So that would be what the output looks like. So we want to use the np argmax function. That tells you, which one of those two outputs is larger. So in the example I was giving, it would have been argmax would have said 0. Right? So this isn't going to work very well because we haven't trained the model. So the model's going to predict randomness, but we can run it and see what happens. So we've got action there, and we'll just pass action in here. Okay, so I have a TensorFlow error. CUBLAS status allocate failed, and I have a fix for this. This is related to memory, so I'm just going to copy this method. The first thing I'm going to do is call config TensorFlow to fix that error. Okay, this didn't work very well. It ran off the screen. Let's see if we can see this again. There it is. So it's just moving to the left. It's not really predicting very well. It is using predictions from the neural network, but the network hasn't been trained yet. So what should we actually do? Well, first, we need to know if the cart has fallen over, we want to stop and retry. So let's say if done, we are going to just print some information, and then we have to break out of this while loop. Okay, so if it fails, it's going to break out of the while loop. Let's just run this again. See, now it's just going to keep trying, but neural network is never getting better. You notice it's going like 9 or 10 steps and then it fails. The memory is increasing, so we're adding things to the memory, but we're not actually learning from it. Let's try to learn from it. And one other thing is we want a goal. So our goal is going to be to reach 500 steps. So let's say if step equal 500, we're gonna if it gets to 500 steps, we want to save this model because we have a trained model that is working. Save it to folder called working model. Great. So now let's train the network. Okay, so let's create, after every single one of these tries, let's go ahead and run a method called learn. Okay, so let's create this learn method. So now we should have stuff in the memory, and let's use it to train the neural network. First thing we want to do is grab a mini batch. So let's create a mini batch size. And I'm going to say the batch size is going to be 10. So in other words, we don't want to use the entire memory to train the network every single time because it's not going to train very well. It's going to overtrain on lots of bad stuff. So we want to continue to feed it examples and have it train little by little and continue to improve. So let's get a mini batch of our memory. And our random sample from the memory, the number of samples that we want is going to be either the length memory. So like when the memory is not full yet, if we've only got 5 things in the memory, then we want to just sample 5 things, or use the batch size, whichever one is smaller. So if we have a small amount of memory, we only want to take that many things. Anyway, that's going to get us a mini batch to train on, and let's create the input and output data sets. So train and Y train. So we want to go through this mini batch, which has the state observation and whether or not it was done. Okay, so what we're going to do is create a Y target. So this is going to be the output that we're going to use for our training data set. We're going to use the model to create this Y target. We're going to say if the model didn't fall over. Ah. We also need to remember the action that we took. So I'm going to add that to the memory as the second thing. So here, Y target row 0, it is going to have a list with 2 items in it, one in the 0 position, one in the 1 position. We want to set whichever action we took to our reward plus the prediction based on the future state. Great. So now we're just going to add these things to these lists. Then I'm create some NumPy arrays, pass into the model's fit function. I'm gonna grab the history, and we're gonna train the model. We're gonna train it for 5 epochs. Now also, I'm gonna print out the history so that I can follow what's going on. We'll look at the loss. Don't necessarily need this, but whenever we run the fit function, it's going to give us the loss value from training. So great. Now we can learn from the examples. Now we can see if this does anything. Basically, we're still just directly using the model. Let's see if this actually helps. So that was pretty good. It kept it upright a lot at first, but you notice it's definitely not consistent, and it's getting worse over time. 310 is pretty high for a first run, but that's kind of an anomaly. Okay, so we notice our memory is growing, it's training, and it is not, the number of steps is not increasing. So it's learning something, but it's definitely not gonna hit that 500 number. It looks like it's overfit somewhere, and it's learned how to just move everything to the right. Okay, great. So what do we need? We actually need a lot more randomness. So we need random movements in our training data set, because remember, it's training and actually holding it upright at the same time. So let's introduce randomness. We're going to do that in the get action function. So basically what we need is exploration value. So I'm going to call this the E value. And then we need this exploration value to decrease over time. So I'll create a minimum. E min is going to be 0.01, and then E dk is going to be 0.799. Why not? So here what we want to do is we want to generate a random number. And if this random number is less than or equal to our E value, we're just going to randomly sample from the environment. Okay, there we go. So yeah, if we're going to generate a random number. If it's less than or equal to our E value, we're going to randomly sample from the environment. The E value starts at 1. So at the beginning of the whole process, it's going to get a random sample. And then what we want to do is we want to decrease this value. So after we've learned from our try, we want to say Oops. We want to decrease the E value by the E decay. Okay, so that's going to introduce less randomness as time goes on. All right, so let's see what that does for us. The interesting thing about this particular way of training cart pole using a neural network is that it might take a long time before you finally get to your goal. And you notice now, it got to 232. That's pretty good. Over time, it should be learning more and more, and eventually, eventually, it'll get to 500. And once we get to 500, we want to save that model. But yeah, it could take a very long time before it actually trains the perfect model. Okay, so that one, I let it go to 278 tries, and it still didn't train completely. So we're going to try a few extra things here. And let's see if that'll get us to 500. Also, I'm going to print out the E value. So that we can see this value decreasing. All right, let's run it again. Okay, that time didn't work either, so we're going to try again. I'm going to put this back to 1. Just continue to try until it actually gets to 500. Okay, so I'm thinking that if it doesn't get it within 50 tries, that we should just start over and do it again. So let's put this number of tries down to 50. And I'm going to create a function called get model. Create model. I'm going to create a variable here called done. How about finished? And run this until it's actually finished. Basically, the first thing I'm going to do is run create model. So I don't need that constructor. So create model, set up the memory. Now, if it gets here, it's going to save the model. It's going to say finished. It's true. So it's going to break out of that. And then we're going to break out of this loop. As soon as it's actually found something with 500 steps, it's going to save the working model. And I'm going to remove the rendering so that it just keeps going and going until it's done. Here, we're going to reset some other things. There we go. Okay, we can see here after doing that, it was able to eventually get to 500. It looks like it worked on the 49th try. Great. So let's try out our trained model. All right, so I'm going to create a new file. I'm going to call it working model. And just because it's kind of a convention, do that. We're going to use model, but we also need to fix TensorFlow error with this little bit of code. Why do I have to do this? I don't know. Load model, working model. There we go. Okay. So we basically want to set up the gym environment and then try to use our model to keep the pole upright and see if it works. We're going to try 200 times to see what happens. Okay, so that's our action. And then we're just going to go. Okay. So we're only going to try. Let's just keep going and see what happens. It ends. Okay, let's see if this will run using my working model. Look at that, it's holding it up. Is it going to get to 500? Like I didn't get to 500, but it did pretty well. It got to 289. Just kill it if it finishes. Let's try it one more time. Now, this model is pretty good. There's no randomness in this. This is just coming directly from the neural network. And will it get to 500 this time? It worked. All right, so we now have a trained neural network model that knows how to keep the cart pole up. That's it. Bye.